In this demonstration, I want to show you how to generate the printouts that are necessary for Project 2 this semester, and also have a brief discussion about the project. I'll go over it more in depth in class, but I do want to go over it with you here just a little bit. First, it's due on October 11th. That should be a Thursday. It's due by 1:45. It's worth 30 points. You can turn it into me, or I tell you down here below that you can turn it into the Stat Lab in CIS 1036. We'll accept it either place. The data that you're going to use is exactly the same as the first project. So you're going to be working with groups with another person, a partner, so groups of two. I did not take off if you didn't work in groups last time. This time I will. So you need to have a partner. I prefer you to find sooner as opposed to later your partner if you need one. Otherwise, you can just expect to get a 3-point deduction, 10%, and that'll be what I do on Project 2 and also on Project 3. Same data set, so I'm assuming everybody at least has one that they worked with for the first part. Hopefully you're able to save it and you can go back to it. All right, so here's what I'm asking for. And by the way, when you turn it in, I don't want this first page. Please don't print off this first page. Start with this page here with who you are and where you're from. And then the first page is our confidence interval page. And actually the project works a little backwards in that the chapter 6 materials first, the chapter 4 and 5 material come later. So let me talk about the confidence interval information. In question 1, I will consider this a large sample confidence interval because you want to do a confidence interval for the mean high price of all stocks. So you're going to use all 65 of your stocks, and that'll be considered a large sample. In this problem, I'm going to ask you for a practical and a theoretical interpretation of a confidence interval. We'll go over these in class when we get to the chapter 6 material. For question 2, this is a small sample confidence interval. I just want you to use the NASDAQ stocks and work with the closing prices. And so you only have 25 NASDAQ stocks, if I remember correctly. It was 40 and 25. Here I want you to tell me what assumptions are necessary, and there's a big difference between large sample and small sample. There's one extra assumption that's necessary with large sample. And just so you know, an assumption we need all over the place. We've talked about this in class, or at least we will have. We need random samples, but for your projects you don't need to assume that you have a random sample because I know you do. I looked at your part 1 and I looked how you took your random numbers out of the hat, the piece of paper, however you did the physical mixing technique. And so I'm going to believe that you have the random sample. So you don't need to state that as an assumption. There's an extra assumption that's necessary when we work with small samples. I want you to state that here, and please be very careful and state that in the words of the problem. And then part B, I'm asking you to make a statement about a claim. I'm claiming that the mean closing price of all NASDAQ stocks is $20. I want you to look at your endpoints that you get on your printout, the printout that you're going to place here, and I want you to tell me how you would respond to that claim. And again, these are things we're going to go over in class. So question 1, a practical and a theoretical interpretation. Question 2, I want you to answer a question, which is our third type of interpretation, and state an assumption. Question 3, which because of when I'm filming this I know we've already covered, a normal probability plot and a stem and leaf plot, 2 of the techniques to determine whether observations are normal or not. I want you to create each a normal probability plot and a stem and leaf plot, and then answer question A. Do the plots indicate that the low prices are normally distributed? Why or why not? What is this? Question 3. Is that how I've got these numbered now? 3A and B. 3B, I want you to create some descriptive statistics for the low prices. And really what I want you to do is some normal work. And so in question 3B here and also in question 4, I want you to do some normal work. This is going to be using the X version of the Z-score. Question 4 should be using the X bar. In both of them, however, we need a value of mu and sigma. Rather than give you a value so that everybody would have the same value for this problem and the next, I'm going to have you look at your data. So I want to print out, I want you to go to look at your all 65 stocks. So use all 65 again. Give me the mean and the standard deviation of your low prices. And you're going to paste that printout right here, and I'll show you how to do that in just a second. And then I want you to answer the question, assuming that this is mu and sigma. I know it's not, but just go with me here. Assuming that this is mu and sigma, and assuming that you have a normal distribution, which probably isn't true. So a lot of assumptions here. But if you had a normal curve with your value of mu and your value of sigma, I want you to go through the normal problem and find the probability that the proportion of all low prices, the probability that X will fall between 15 and 35. And I want you to take me through the steps. Start with the X's, go to the Z's. Get full credit. You need to be really good here. I want the picture perfect. I want to see the X work. I want to see the Z work. I want to see probabilities shaded. I want to see them labeled from the table. And I want to see a final answer. all right there. There's a lot of points tied up in 3B. Likewise, in 4, I want you to find the probability that if you were to take another sample of 100 stocks, find the probability that the average price in that sample of 100 stocks would be less than 30. Find the probability X bar is less than 30. And again, I want you to show me all the steps. A lot of points here. Give me the X bar work. Give me the change it to Z-score. Show me the Z work, shade probabilities. Tell me what those shaded regions are from values you either know about because you know something about the probabilities in a Z distribution, or you get from the table, and then give me your final answer. So that's the work I'm looking for. Now let's go over to statistics, and I'll show you how to generate the printouts. Okay, here I am in statistics, and I have a data set similar to yours. You can see as I scroll up here, different letters. I think you guys are working with the R's and the D's. This semester I was working with the S's and what am I working with down here, L's. But you can see same split, 40 New York Stock Exchange stocks. I believe it's 25 NASDAQ, yeah. And so I'm going to go and generate the 5 printouts. Now the way I'm going to do this is I'm going to do all the printouts that require all the data first, and then I'll do the one where we just want the NASDAQ. So working with, going from the back of the project, I'm going to work with the low prices. So I'm going to go and get the printout that's necessary for the very last problem. So I'm going to go to statistics and summary statistics and descriptive statistics. I'm going to click on that. We're going to spend a lot of time in this menu. I'm going to choose low. Now I'm using all 65 stocks. I'm going to ask for all I need is the mean and the standard deviation. I don't need that. And I'd like to see sample size too. And so there you go. This will be the printout that I will plug in. So I'm going to copy that. I know some of you guys have to do some other things working in the application gateway, but those are the numbers that I need to see and my TAs need to see when we grade this problem here. I made the box a little big. Okay. For question 3B and also for question 4, I'm going to use the value of mu of that number and the value of sigma of this number here. And I'm going to assume I have a normal distribution here in B. Really, it doesn't matter in part 4 because I'm assuming we're working with a sample size 100. But go and solve an X probability for me here. Use those numbers to solve the X bar probability. So that's one of the printouts. The next printouts I'm going to look at are the stem and leaf plot and the normal probability plot. So let me do the stem and leaf plot because that's where the box that I was at on the project. So you know how to do this. You did this for me in the first part. Stem and leaf plot, low, okay. Again, I'm going to be able to copy and paste. Now, depending on your picture, you may need to resize my box a little bit. So let me go back to Word. So this will be my stem and leaf plot. Yeah, look at that. It fit great. I have really skewed. I would say the low prices. Don't tell me the data. Be more specific. The low prices are skewed to the right in my case. Now, the normal probability plot, to get that, we go to a different menu. So I'm going to go to the randomness normality test and come down here to normal probability plot. I'm going to click on that, and again I'm going to work with the low prices. Remember, the straighter the plot, the more normal the data. Now it has to be really straight. These points almost have to fall exactly on this line for you to tell me it's normal. But again, because I'm working on my PC, it's really easy for me to do this. I can just copy and then paste. You may have to do a little bit more work within the application gateway. I'll resize that a little bit, but those are the plots that I'm looking for. Okay, easy enough. All right, now I'm going to go all the way up to the top because again, I'm using the entire data set for these. I want a 97% confidence interval, and I'm working with the high prices. So now I'm going to go back to the summary statistics, descriptive statistics. I'm working with the high prices. Oops, there we go. I don't need that. I don't need that. I just need the sample size and the confidence interval. And I asked for 97. So I'm going to change that number there. So high, 97, just these two boxes. And this is the printout I want. So I'll copy that. And I'll bring this over. And actually, I'm going to end up taking some of that out because to make it fit, I'm going to just look at these guys here. So there we go. And this is the confidence interval that you're going to interpret for me. You're going to give me a practical interpretation in the words of the problem. Don't tell me about mu. Don't tell me about average. Don't talk about data or prices. Be specific. Be very specific. And then a theoretical interpretation. Now, the toughest printout on this whole project is this one here, because I just want you to work with the NASDAQ stocks. And so we're going to need some way, so I can get out of all these. Let's get rid of all this stuff here. Get out of that guy, get out of that guy. I need some way to tell statistics to just work with the NASDAQ stocks. Now, for me, it's really simple, because again, I'm working on a PC. Some of you guys may be able to get your Macs to do this on the application gateway. I just left-clicked, and I highlighted all of the New York Stock Exchange stocks, and now I'm going to right click and I'm going to say omit, and I think you can see this on your screen. They faded to gray. Okay, if I want to bring them back, I'm just going to highlight them again, and then I'm going to say restore, and then they're back. Okay, now I know that's not going to, well, I shouldn't say I know. I think some of you are going to have trouble with that. So there's another way. I'm going to go to the transformations menu in the data menu. Nope, that's not right. I'm going to go to the omit select cases menu. That's correct. I'm going to go here and I'm going to say omit if. Now there's a lot of ways I could do it, and I guess the easiest way is exchange is equal to, which ones do we want to get rid of? And I got to spell exchange right. We want to get rid of the zeros. We want to get rid of the New York Stock Exchange stocks. So let's see where I'm at here. Okay, this will be perfect. So I'm going to put this box, I'm positioning this menu, so you see some zeros up top and you see some ones down below, or at least you should see that, because when I hit go, you should see these zeros fade to gray. And it tells me that 40 cases, which is the number of New York Stock Exchange stocks I have, are omitted. If I want them back, all I have to do is come back to this menu and hit restore. They're back, but I want them to be gone, so I'm going to hit go. All right, so they are now still in my data set. I haven't deleted them, but I've removed them from the analysis, and statistics says I've omitted them. And so now we need to generate the printout. I'm going to go back to descriptive statistics. I'm going to keep N. I'm going to keep confidence interval, except this time I'm going to choose the closing price, and I'm going to change this. I asked for 94%. And I'm going to type OK here. Oh, that's a perfect printout for me, because I know what, whoops, Control C is what I wanted. I hit Control V instead. And now I'm going to go and put it in here. I love this printout. And I want you to tell me the assumptions that are necessary for this work to be valid, and it's because of the small sample we have an extra assumption. We'll talk about this. In fact, we'll talk about this probably the week that the project's due, whether you're a Monday or Tuesday student. It'll probably be on that day of the week. But then I look at it. So we'll talk about what to do, and what I encourage my night students to do. Come Monday night, come Tuesday night with everything else in your project done, and leave 2A blank. And I'll come in and fill in the blanks for you. I'll help you with that one. But 2B, perfect printout for this. So I claim that the mean closing price is 20. Look at that printout. I couldn't have guessed for a better printout. I didn't look at this ahead of time. But is mu equal to 20? Well, if you look at my printout, 20 doesn't fall in between those numbers. It's really close, right? My lower end point's 20.124. And we're going to talk about in class how we make conclusions, or how we may answer those claims or questions. And it's based upon whether the value we're asking about, the value 20 in this case, falls inside or outside that confidence interval. In my case, it's outside, just barely. We'll see what you get, and we'll talk about how we make those interpretations. Make sure you make a statement using your reliability. So I'm going to say at the 94% confidence level, or I am 94% confident that. I want to include that reliability as part of that statement. So anyway, that's how you generate the printouts. I've given you some insights into what I'm looking for, but I'm going to talk about it in class with you guys as well. So join me, and good luck.